Good morning. This is Andrew from the MPC Framework team. I'm back for another demo of JumboSwap. We're going through this. Again, don't worry, you don't need to see the previous demo. I want to show off our cross-browser compatibility and also talk a little bit about some changes that have gone on under the hood. We'll get to those in a minute, but in the meantime, if you haven't seen JumboSwap or MPC before, so MPC is this special cryptography where it's a protocol that uses cryptography that allows people to do some computation with each other where everybody submits their input and everybody gets the output, but you sort of don't see anything that goes on in between. Even though the calculation could be quite complicated, all of those internal details, intermediate values, that would happen in a computation, those still kind of happen, but nobody gets to see them. It's really powerful. You can learn more about it elsewhere, but that's the idea. So anyway, for this JumboSwap app in particular, which utilizes this MPC, it implements this thing where, if everybody coming to the protocol has some piece of property, something they have that they're interested in trading with other people. And so you can read the description here to get a little bit more of an explanation of why you would want to do this. I think there are economic reasons why it is a good idea to trade in this way. But yeah, basically the app can find these complex swapping schedules, not just this person would rather have that thing and the person with that thing would rather have their thing. You can also have this kind of three-way swapping situation going on. And so yeah, I'm not sure whether that's the result we're going to get, because I'm not necessarily going to constrain the system in this way to make it so that that's the only possibility. Yeah, that's the idea. So let's show it off. So I also have, by the way, so this is Brave on the left, which is a Chromium browser. Think of it as just Chrome, really. In the middle, we have Safari, Apple's browser. On the right, we have Firefox. And in a minute, we're going to also have nothing sensitive on there. In a minute, we're also going to have Brave on my phone, on my Android phone. So you think of it as Android, the Android flavor of Chromium will be the fourth participant. We'll get to that in a minute. So anyway, the way to do this is you just say, all right, somebody has to play host and host the session. So we get this QR code, but it's easier on the computer. I'll use the QR code on my phone, but within my computer, it's easier to just copy the code. And then within another browser, I can go join, and I can find, you can have the camera, paste into there, and it should connect. Yep. And same thing with this one. It's a camera as well. Paste. We do that. And then we should start getting these ping times. So we can see these two are already communicating. But then, yeah, okay, so all three are communicating with each other because every participant has a direct secure channel with every other participant. This is an important property of MPC. Otherwise, you don't know who you're talking to. And so you can't be satisfied that everybody is getting the correct result of the calculation because you could be talking to somebody else that you didn't think wasn't the person you intended to do the protocol with. So it's an interesting subtlety that's quite important, I think. Anyway, so let's get my phone to join. So previously I used the host QR code to get the code from the host was distributed to the other participants to get them to join. But we can actually get the code from any of these participants. So I'll use the QR code from Safari, scan that with my phone, and then we should see the new device appear on here when it connects. Yep, see, there it is here. And then it will start connecting. There we go. We're using a free service to bootstrap the WebRTC connection, so the initial connection phase can be a little bit slow. But there we go. Now they're all communicating with each other. So once we have here, we need to say everyone needs to identify themselves. So this one's Brave, this one's Safari, and this one is Firefox. And my phone's one I will call phone. You can see that showing up here. Cool. And so I'm just thinking back to the sort of demonstration items. You can see in my testing, I just use A, B, and C. But let's use, what was that chocolate. So let's say Brave has chocolate, Safari has the ice cream, and Firefox has not a cookie. What's it called? Hold on, just open a new tab. Cake. Okay, let's say that Firefox has cake, and right, my phone is going to have the donut. Okay, so once we know what we're trading with, everybody can see that they're ready, they're satisfied that this is the setup that they want to participate in the protocol with. Everyone says ready, and it's still waiting on my phone, so when I press ready on the phone, everybody will proceed to the next stage. So now from here, everybody has to say what they would like to have. So what I'm going to do is I'm going to set up something a little bit similar to the example where, the Safari that has the ice cream, they want, for whatever reason, they would like to have the donut. That's the example. But everybody else, I'm going to say that they're willing to trade for everything else. So the way this calculation works, is that it will explore every possibility. And that means that there should be a way to satisfy this. You can think of one pretty easily, but there are many different swapping schedules that will satisfy these constraints. And so the protocol is going to pick one of those. And I also need to do this on my phone. See that here. I should probably hold this up now. And so everybody goes to submit and submit. You can see here we're waiting on Brave and Firefox. Submit, and then it will start doing the calculation. Just move this down so that we can see all four of them. There we go. I'm going to start going. And it shouldn't take too long. And there you go. So everybody should get the same results. And what do we say? We said that the person who wants the ice cream, which is Safari, should be getting the donut. So Safari, give your ice cream to phone and receive phone's donut. Okay, so it did a direct one-to-one swap, but I think that Brave is also doing a one-to-one swap with Firefox. Is that right? So Brave, yeah. So there's a one-to-one swap between Brave and Firefox and a one-to-one swap between Safari and the phone. And that's how it works. So the change that's happened under the hood is that we've improved the circuit generation. So this actually runs a bit faster than it used to. I think it's something like 3 times faster actually. This app was particularly benefited from the speed up in the way we do the circuit generation. So that's really cool. But also there's this new summon API that I'm going to write about elsewhere. But basically the way that you write circuits, which I think was already pretty cool because of, the fundamental thing was still there, which is that you get to write your circuit in a TypeScript-like language. So it's doing that, but there's this new IO API that makes it much more natural to specify your inputs and your outputs. And that's there too. So be on the lookout for updates about that. But anyway, hope this was interesting, and I'll see you in the next one.